Señoras y señores, bon tardes. This is only my word in Portuguese. I am going to speak in English because, unfortunately, I don't know speaking in Portuguese. Sorry for that. Okay. Today, I am going to tell you two success stories. One is AIRBUS, and the second one is the use of composite material in aviation. My name is Jacinto Tortosa. I represent here. I am the head of a technological center in Spain called FIDAMC. It's a foundation fully dedicated to research, development, and innovation. I mean, industrial application, very close to the industry, fully dedicated to composite material. I have, the foundation have some relationship in Portugal, for example, with Universidad Atlántica is here. We have a strategic collaboration in order to promote engineer, people, competence in composite material field. And also we have some European project with the aeronautical cluster in Portugal. My wish is we have to continue to improve our collaboration. It's very important to have a collaboration in aviation and in composite material. Okay. This is the index. I am going to talk something about AIRBUS because the foundation is 50% is coming from AIRBUS and the other 50% is coming from the Spanish government. Then it's a private-public techno center. AIRBUS have got a lot of techno centers around the world, mainly in Europe, one in UK, one in France, one in Germany, one in Spain, fully dedicated to composite material. Then I am trying to make a historical evolution about composite material in aviation, mainly in AIRBUS and mainly in commercial aviation. And finally, I am going to dedicate some work about what happened in the future. What about the future? The future is the most important. I am going to begin telling you something that happened last year in AIRBUS. It's a video, Achievement 2016, AIRBUS.
Airbus T-Mobile is very grateful to JetBlue for the confidence you have shown in us.
This leadership university is an essential tool for our company. It is a transformation and experimentation engine for all of us in the future.
Europe's largest aircraft manufacturer, Airbus, has started construction of a new facility to finish wide-body planes in Tianjin here in northern China.
I'm proud to have Singapore Airlines receive our 10,000th aircraft today.
Three, two, one.
AIRBUS is an international company. It's the reference in Europe. This is most important for us. Should be our leader, our tractor in Europe. When we talk about a company which is close to 140,000 employees, close to 70,000 million of revenues. You can see other figures, 35 countries, more than 185 allocation in the world. European, 30%, non-European in terms of sales. In terms of staff, 20% non-European, 20% non-European workforce, 80% European. This is a great company. This is AIRBUS. Now is a year of first, progressing, changes, even the last change you saw the screen. AIRBUS Group has been changed through AIRBUS, only AIRBUS. Now the trademark is AIRBUS. In AIRBUS, we have three business units. One is commercial. You can see here, 70% of the revenues are coming from commercial business unit. You can see here. And then 70%. More detail in this slide, you can see. In the case of commercial, we have a very nice, very important revenues and employees and so on. You can see here, and very nice portfolio of products. We can see the single aisle, short range, the wide body family, 330, 340, our baby 350 extra wide body, and our flagship 21st century is A380. It's a video only 20 minutes in order that somebody here could buy some A380 in the future. This is the product. This is the commercial business unit in AIRBUS. This is the most smooth, the most, in terms of safety, the most smart aircraft. It's the flagship 21st century. But we have another two business unit. One is defense and space. You can see here the figures. It's more or less the 15% of the AIRBUS. 70% AIRBUS commercial, 15% defense and space, and 20%, and 50% helicopter, okay? In this case, I have another product that you can buy today. We can have a deal in order that you buy this product. This is a very nice product because this is a multi-rudder proposal MRTT. This is an operation, very difficult operation. It's refueling. in the sky, not only with the fighter, but also with military transport aircraft. This is A400M. This operation is complicated. It's very nice. This is a developed made in Spain. An helicopter. Helicopter, you can see the figures, and you can see our portfolio of helicopter in AIRBUS. This is the figures, portfolio, civil range. I'm not going to spend time in order to relate every product, but you can see here a military product. At the end of the day, AIRBUS is the reference, 3 business units, commercial, most important, defense and space, and helicopter. You can see here that if you have a look to this template, you can see that we are talking about different projects, not only in service. You can see here in service project, but also in the conceptual phase, in the development phase, and you can see a lot of projects. I am not going to tell you. This is an example in defense and space. We are talking about fighter. We are talking about military transport, aircraft. We are talking about unmanned vehicles, unmanned devices, etc. And of course, I don't know if you saw in the video that we have a branch in Silicon Valley in order to develop technologies looking at the future. Digitalization, automation, connectivity, and so on. But today I am going to talk only about platform, about our planes, our products. Now it's time to talk about the historical evolution of composite material in aviation. In this case, I am focusing in commercial aviation and focus on AIRBUS. Okay, we have to take into account the following. When we talk about the operation, when we talk about composite material, the most important parameters, most important is weight. Weight, and weight. But weight is not equally important in short range than in long range. You can see here an example. When you have a look to an operation, typical operation, short range operation, single aisle family, the total operation is 185 minutes. But the fuel weight zone is only 10 minutes, because the rest is boarding, fueling, handling, taxi, descent, taxi, and then the percentage is 54%. In the case of long range, the percentage is 82 when we compare, when we make the same rationale. Regarding fuel weight zone, in this case, is more important than in short range. What is the conclusion? In my opinion, and the conclusion is wide body, long range is going to be manufactured continuously, increasing composite material and continuously with composite material. But the problem is short range. In this case, we have to talk also about metallic. I am going to tell you something after. About the history. Composite material are using in all devices, in all aerospace devices, mainly in commercial, but also in helicopter, military transport, and space. You can see here a launcher. We use composite material in all our products. We started in Spain with CASA, with an American program, F5. We started introducing composite material, as you can see here. And we transfer this knowledge, this technology, from military aircraft, from fighter aircraft, to civil, commercial. In this case, you can see in 1970s, we use carbon fiber, glass fiber, in different components of the aircraft, more or less 5% in the A3, A310. In this case, we can see the vertical tail plane, we can see elevator, rather we use glass fiber, carbon fiber, and aramid fiber. In 80s, what happened when we launched single aisle, A320? We increased the use of composite material, horizontal tail plane, vertical tail plane, belly fairing, fan cowl, glass fiber, carbon fiber, and aramid. We continue using composite materials with long range. In this case, you can see that the HTP horizontal tail plane is the first structure manufactured automatically. The former use of composite material was manually operation. In the case of A380, we increase the use of composite material. You can see that the rear end, horizontal tail plane, vertical tail plane, and section 19 of the fuselage in blue color is made of carbon fiber. This is the first time that a section of fuselage were made in a commercial aircraft, A380. Belly fairing, fan cowl, even we use quartz fiber in the nose of the plane. Now we move to A400M. You can see here the wing, the skin, the aileron, the spoiler, carbon fiber, horizontal tail plane, torsion boss, leading edge, trailing edge, vertical tail plane, skin, and so on in the fuselage. And then we increase the percentage. When we launch A350, we call this is a black plane because all the structure that we can see is black. It's carbon fiber or composite material. 55% is made on composite material. The same case in the Boeing 787. You can see that the complete fuselage, complete wing, complete rear end, fan cowl, belly fairing, all the different components of the structural configuration is made in composite material. Now the challenge is maintain that, maintain it. How maintain this position in the future? This is a summary. In the 40 last year, AIRBUS has been continuously increased the use of composite material in their devices, in their planes, in their aircraft. You can see here, 70s, 5%, and now 10 times more. This is a clear success history. But we have to maintain. And you can see the evolution in percentage from 5 to 10 to 25 to 30 to 55. This is the evolution of the use of composite material in our commercial planes. You can see here a distribution of material in the complete width of the craft. We talk about titanium, about alloys, aluminum alloys, and something like that, a little bit. You can see here titanium, steel, aluminum, lithium, other alloys, and 53%, 55% in composite material. This is the real distribution of material in our baby aircraft, extra wide body, A350. This is the same case in the Boeing 787. Then this is a history of success, as I mentioned before. And now, what about the future? How many times? Yeah? Oh, how many? What about the future? Okay, the future. We have to maintain, and we have some challenges. Of course, this is clear, the use of composite. And it's clear the no use of metallic material. But the problem is that now we need to compete. I mean, metallic alloys has been improved continuously. And now alloys compete with composite material in short-range aircraft. This is the case. When we launch a new short-range, we have to demonstrate that if we make wing, fuselage, rear end, and so on in carbon fiber composite material, is because our scenario is better than metallic. This is the challenge. Cost reduction, multifunctionality, manufacturing technologies. You can see here 40% fuel burn. Talking about eco-efficiency, I don't know now because you know the regulation, somebody mentioned this morning in Europe and so on. And then this is a list, only 1 minute more, sorry, a list of, we have to develop carbon fiber or other fiber, other precursor, low-cost precursor. We have to develop new material as resins, as oscillatory material at high temperature and FST material, new adhesive, new thermoset reduce the cost of our processes to make robust processes. Now, for example, in FIDAMC, we are developing thermoplastic technology. This is a new technology in order to face the future. It's a better future for us, thermoplastic. You can see a list, but at the end of the day, cost reduction, eco-efficiency, high performance, etc. Thank you.